Hello students, myself S.K.Jadhav from Department of Electronic Science, KTHM College, Nasik. In previous lecture, we have discussed about the basic logic gates, definition of logic gate, applications of logic gates, and working of OR gate using switches and diodes. In this lecture, we will discuss about AND gate using switches and diodes and NOT gate using switches and transistors. Let us now talk about AND gate using switches and diodes. The definition of AND gate is AND gate has two or more inputs but only one output. It is known as AND gate because the output is high only when all the inputs are high. For other input, the output is low. The logic symbol of AND gate is shown in figure A. AND gate performs logical multiplication or AND function. Logical expression of AND gate is y is equal to A dot B or A into B dot should be read as AND. Similar to OR gate, AND gate can be implemented using switches as shown in figure B, in which the switches are connected in series. Let us now consider an electronic circuit consisting of battery, switches and lamp to explain AND function. Referring to the switch analogy, when both the switches are open, that is at zero level, then no current flows from battery to lamp, thus lamp is off. When one of the switch is open, that is at logic 0 level, and the other one is closed, that is at logic 1 level, then the lamp is off. That means the output of AND gate is 0. As the circuit is not complete, there is no current flowing from battery to the lamp, thereby keeping the lamp off. Thus, any one or both inputs are at logic 0, then AND gate produces logic 0. The output of an AND gate is high only when all of its inputs are in the high state. That means A is equal to 1 and B is equal to 1, or when both the switches are closed, then the lamp will glow and the output is high. Then figure C shows the AND gate using diodes. Let us now we will discuss the working of the circuit. The first case is when A equal to 0 and B is equal to 0. When A and B are 0, then both diodes are in forward bias condition and they conduct and act as an closed switch, and hence the output will be 0 because the supply voltage VCC will be dropped across resistor RL. and therefore the output Y equal to 0. In terms of binary, when A equal to 0 and B equal to 0, then output Y is equal to 0. That is shown in the table. Then the second case is A equal to 0 and B equal to 1. When A equal to 0 and B equal to 1, then diode D1 will go into forward bias condition. That means diode D1 is in conducting state and hence acts as the closed switch. At the same time, the diode D2 is in reverse bias condition. That means the diode D2 will go into non-conducting state and acts as an open switch. Therefore, output Y equal to 0. In terms of binary, when A equal to 0 and B equal to 1, then output Y is equal to 0. That is shown in the truth table. Then third case is A equal to 1 and B equal to 0. In this case, if A is high and B is low, the diode D1 becomes in reverse biased and hence acts as an open switch. At the same time, diode D2 becomes in reverse bias. That means D2 will be in non-conducting state and hence acts as the closed switch, and therefore the output Y is low. In terms of binary, when A equal to 1 and B equal to 0, then the output Y is equal to 0 as shown in the truth table. Then the fourth case is A is equal to 1 and B is equal to 1. In this case, when both inputs are high, then diodes becomes in the reverse bias. That is, both the diodes are in non-conducting state and hence acts as an open switch. Since D1 and D2 are in off condition, there will be no current through the load resistor RL. The output is equal to the supply voltage, that is ideally equal to plus 5 volt or equal to VCC, and therefore the output Y is equal to 1. Thus, in case of AND gate, the output will be high only when the inputs A and B are high. In terms of binary, when A equal to 1 and B equal to 1, then the output Y is equal to 1 as shown in the truth table. Then NOT gate using switch and transistor. Let us now discuss the NOT gate using switch and transistor. The definition of NOT gate is: it is a gate with only one input or single input and only one output. It is so called because its output is complement to the input. It is also known as inverter. It performs logically inversion or complementation. Figure A shows the logic symbol for NOT gate. The Boolean expression or logical equation of NOT gate is Y is equal to A bar. The purpose of inverter is to change one logic level to opposite level. The low level at the input produces a high level and high level at the input produces a low level. In terms of bit, it changes 0 to 1 and 1 to 0. The NOT gate can be thought of like an electrical circuit as shown in figure B. Let us now consider an electronic circuit consisting of battery, switch and lamp. To implement simple NOT gate or inverter, the open switch is corresponding to logic 0 turns the lamp on, indicating logic 1. The closed switch corresponds to logic 1 turns the lamp off, indicating logic 0. When switch A is closed, input is high and the bulb will glow. That is, the output is low and vice versa. The NOT gate inverts or complements the input. The NOT gate can be constructed using transistor. We know that a transistor is used for switching or amplification purpose. Due to this property, we are using it as a switch for NOT gate operation. The transistor used for the design of logic gates depends upon the transistor's switching speed. There are three modes of transistor, namely active mode, saturation mode and cutoff mode. Out of these, we are using saturation mode and cutoff mode for NOT gate design. Figure shows the transistor NOT gate. Here, the transistor is connected in common emitter mode. Let us now we will discuss the working of NOT gate using transistor. When the input A is high, that is at logic 1, which represents plus 5 volt at the input, the base of the transistor will become positive. This causes the transistor to conduct heavily. That is, the transistor will switch on. That means very high current will flow through the transistor and it is driven into saturation, and all the current then passes through its collector to the emitter and into ground, so that the total supply current will be drawn by transistor. This means that no voltage is measured at the output port, which is considered as low state. In terms of binary, when A equal to 1, then the output Y is equal to 0 as shown in the truth table. Then in figure B, when A is equal to 0 or A equal to at 0 volt or A equal to low, the base of the transistor will become negative. This negative potential causes the transistor to go into cutoff mode and there will be no current through the transistor. That means the collector current or IC is equal to 0. The transistor stops conducting and goes off. This means that the supply voltage plus 5 volt will be measured at the output port and it is considered as high state and hence the output Y is high, that is equal to VCC. In terms of binary, when A equal to 0, then Y is equal to 1 as shown in the truth table. Hence, it is seen that whenever input is high, the output is low and input is low, then output is high. In this lecture, you have learned the basic gate, that is AND gate and NOT gate. That means the working of AND gate using diode and switches. Similarly, the working of NOT gate using transistor and using switches. Thank you.